I'm a senior tutor for mathematics, GCSE. All right. So, a little bit about myself. I am basically an undergraduate student for computer science. I've been associated with the field of teaching for over 7 years, specifically for GCSE for over 4 years. Right. So, I'm well versed in the syllabus. So, the first and the most important topic of GCSE exams is numbers. All right. So numbers, right? They are very commonly used in our syllabus. They are one of the most founding members, like founding systems to go about in the syllabus. All right. So there are different type of numbers you might be aware of. All right. One of the most common type of numbers is what we talk about is a real number. All right, everything is a real number. Any number that you see is a real number, right? And now there is a further division when it comes to real number. Real numbers might include any number from, like, starting from zero. All right, so this is indicated as a number line, right? What I'm drawing right here is a number line, right? This is a number line. This in between is 0, and this side is positive, right? So it goes like 1, 2, and so on to positive infinity, right? So to the largest number that you can imagine, you can go in the positive side. All right. And in between 1 and 2 there might be like 1 point, there might be um 1.1, right? 1.01, 1.02, any number for that matter is a real number. Similarly, on the other side, it goes like 1, -1, and -2, and similarly to the negative infinity. All right, so any number in the negative side that you can imagine is a highly negative number. All right, let's suppose negative 19.9, or maybe 19,009 127. All right, so it's a real number. And if I write 0.01, it's also a real number. So any number for that matter of time is a real number, whether it be positive, whether it's negative, it's a real number. All right, I hope things are very clear, right? And now, to start off with the topic, I'd formally begin with different types of numbers. So, with real number being very clear, there's a certain aspect which is called a rational number. All right, so this is topic typically a 1 mark question in the exam, where they ask you what's a rational number and what's not a rational number. All right, so any number, what's a rational number? Does any one of you have any ideas about what's a rational number is? If you have, then do comment in the comment section, and we'll discuss it. Similarly, there's another number which is called an irrational number, right? So a rational number and an irrational number. So what's an irrational number? So the comment sections are open for you guys. You guys may or may not comment. If you guys may comment, then I'll read it out and see if you've guessed it right, you have the right answer. All right, so begin with a rational number is basically any number that can be divided. All right, any number that can be divided is called a rational number, right? So a rational number is any number that can be divided. Let's say if I were to give you an example of a rational number, I'd probably give you what? Let's suppose any number which is 61. 61 is a prime number, although it's a rational number, right? Anyways, I say 62 or maybe 60. Can 60 be divided with any number in the world? It can be, right? So it's basically a rational number. Similarly, 1 divided by 2 is a rational number, right? And it's probably going to give you a decimal answer, right? It's going to give you 0.5. right? Similarly, any number, let's say 3 divided by 7 is a rational number, right? It's going to give you something in decimals. Similarly, any number which can be divided is basically what? A rational number. Likely said so. What's an irrational number? Irrational number would be any number which cannot be divided, right? Any number which cannot be divided, like it cannot be written into fractions, right? Any number which cannot be written, any number which cannot be written as a fraction is an irrational number, right? Any number which cannot be written as a fraction is an irrational number, right? So what do I mean by that? So there are a specific type of numbers. There are very limited type of numbers. There are very limited numbers which are irrational, right? Let me give you an example of a few, and you'll get it. Okay. So if I say that I have a number such as pi. I hope you've all heard of pi. What's a pi, right? We usually write it as like this, and in maths we write it as pi, right? So what's the value of pi? Does any one of you know what's the value of pi? So pi is typically equivalent to 3.142. It is rounded off to 2. All right here it's rounded off, but it's a very long number. It's a very long number. It has 1,000 decimal places or more. All right, so people in competitions, they used to learn this number just to show off how great their memory is. All right, so pi is basically rounded off to 3.142. However, we have devised a number called 22 divided by 7. If you do this, and it will give you a value which is very closer to pi, but pi, this number cannot be achieved using decimals. All right, if you see the whole decimal number of pi, because it's such an extensive number, you cannot comprehend it into a fraction. All right, similarly, that is why it's called an irrational number, because um, its value is unknown. All right, it cannot be divided into a fraction. Similarly, there's another example, which is under root 2. All right, so if you guys quickly take out your calculators and do under root 2, you'll get a value which is very large. uh, Similarly, let me just write down the value of under root 2, and it's somewhere around this. All right, so this value which I've just written right now cannot be written as a single fraction. You cannot write this whole value in a single fraction, right? That is why we say that it's an irrational number. So I hope this thing between rational numbers and irrational numbers is very clear to all of you, right? Is there any confusion at any point in time? You just message in the chat and I'll be responding to it. Okay. Now, moving on. What's another thing that's included? Um, there's something called there's something called a square number. So can anyone tell me what's a square number? Square number. All right, if you guys comment, it's going to be a very interactive class, and I'm sure you guys will enjoy it as well. So, can any one of you guess what's a square number? Okay, so typically a square number is any number that can be obtained by multiplying a single number with itself. All right, what do I mean by that? Let me just first write down the definition over here. So a square number is obtained All right, so a square number is obtained uh, when multiplying a number with itself. Okay, so that's why we call it a square number. Right, so what do I mean by a square number? Any examples that come across your mind? Anything? So a square number is typically, let me just give you an example. So if I say that I'm multiplying 6 with 6, all right, so 36, which is the output, is a square number, right? It has come across. Okay, so I've gotten a comment that I might be going too fast. So square number. If you do not understand any part, just tell me which part is it that you do not understand, and I'll repeat it for you. Okay, don't worry about it. So let me just continue with what I was saying. If you do not understand anything, just let me know which thing do you not understand, and I'll explain it again. Okay. So I was telling you, what's a square number? Square number is any number that is multiplied with itself. In usual GCSE exams, it is advised to all of you that you should remember a square of each number from 1 to 12. All right, let me just write a few for you. All right, 1 multiplied by 1 is going to be what? It's going to be 1. Right, similarly 2 multiplied by 2 is going to be what? 2 times 2 is 4, and then 3 squared is what? 9, right? 4 squared is 16. So you guys should memorize it up to 12. 12 squared is what? 144. So it is advised that all of you should remember this, because one of the exams in GCSE is going to be the one without calculator. So in exams without calculator, it becomes increasingly difficult for you to remember the squares, right? So it's advised that you guys remember it. Okay, then there's another type of thing is called surge. Have you guys heard of what surge is? Do you guys know what surge is? Perfect. So I think Joris answered the question which I asked earlier, which was regarding the square numbers. So he has answered it correctly. Now, if I ask you what's surge, okay. So does any one of you have any idea what surge is? So basically, surge is a number, like surge number are a number which can be obtained by multiplying or sorry, if any number which is obtained by like taking a root of any number, right? It's basically what's called a surd, right? So when I say that by taking a root of any number, what do I mean by that? Any number which is obtained by taking a root of any number. All right, let's say that if I write root of 2, that means it's a surd. Or I write root of 4. So what's the answer of root of 4? What do I mean by that? What do I basically mean by that? How to calculate the square roots is basically um, taking LCM of a number. Okay, taking the least common multiple of a number, and with this is the next topic that we're going to move on to. What's uh what's an LCM? What's the LCM of a number? How do we calculate what's LCM? LCM is basically LCM. If I write it down for you, LCM is basically least common multiple. Okay, so LCM is least common multiple. All right. um And if I show you how to calculate an LCM of a number, so it's basically, let's start with 4. Okay, so the basic number which 4 is divided by with is 2, right? So 4 divided by 2 is 2, so we get 2. Now 2 can be further divided by 2 as well, and we get the answer 1. So we stop when we get 1. All right, so we're gonna write it down. We're gonna write these are called multiples. These numbers are called multiples. All right, so we write these multiples down. 2 multiplied by 2. If there's nothing written over here, it means that it is 2, so it's a square root of 2. So what do we mean by square root of 2? We take two numbers which are common and multiple, so we take them out as single number. Okay, so we take 2 out and there's nothing left. Okay, if there's nothing left in it, uh, square root of 1 is 1, so the final answer would be 2. Okay, so that means that the square root of 4 is basically what? 2, right? If I say that um, it wasn't, there was some number written it or written over here, let's say that 3 was written over here and the number in between was 27. So how do we do this? We take 27, all right, and then we try to divide it. Okay, so what's this minimum number that can be divided by 27? Okay, so starting off, usually what we do is we start off with the least numbers. Okay, so what are the least number? What are the minimum numbers? 2, 3, 4, 5. These are the least numbers. So can 27 be divided by 2? No, it can't be divided by 2 because it's an odd number, and only even numbers can be divided by 2. So can it be divided by 3? Let's say yes, it can be divided by 3. All right, if it is divided by 3, we get 9, right? Can 9 be divided by 2? No, it can't be. Can 9 be divided by 3? Yes, it can be divided by 3. So we get 3 in the answer, right? And now can 3 be divided by 2? No, it can't be. Can 3 be divided by 3? Yes, we get 1. So when did I say we stop? We stop when we get 1 over here. All right, let me just quickly write these down. Yeah, in this. Okay, so we get 3 times 3 times 3. So these are the multiples, and what we needed to find out, we need to find out the cube root. This is called a cube root. Okay, so this number, if there's no number written over here, it means that it's 2. Okay, if there's a number written over here, it means that we have to form pairs of that number, right? It was 2 over here, so we found pairs of two numbers, right? And if it's pair of 3, if it's 3 written over here, then we are going to find out the pair of 3 numbers. So this is a pair of 3 numbers. We take this out, we are left with 3 root 1, and hence the final cube root 1, and hence the final answer would be 3. So this means that cube root of 27 is equivalent to 3. Did you guys understand this? Or is there anything that you did not understand this? This is me just trying to show you how to solve the questions of surds. All right. Now let me just give you a few questions so that you guys can work around with me in the class. So let's say that I have given you the cube root of, um, let's say that I've given you a cube root of 50. So how do we do this question? Take 2 minutes, and it's very easy if you follow the right step. If you follow, first take the LCM of 50 and then do the working. Okay, it's going to be very easy. So get back to me in 2 minutes. All right. All right, so this was the outcome of LCM when we took LCM of 50, right? So we get maybe it's not a square root, maybe it's a square root. Okay, it's not a cube root, it's a square root. So what do we get? We get multiples in form of 2 multiplied by 5 multiplied by 5. Okay, so now we do not have anything in front of the root. That means it's a square root, so we need to find, make pairs of two numbers. Okay, we don't have a pair of 2, but we do have a pair of 5, so we take out 5, so we get 5, and what's left in the root is 2, right? So the answer of root 50 is gonna be what? 5 root 2. So this is how you basically solve any square root or cube root questions of different types. Do you understand this? If you have any questions with regard of working or with regard of the concept, feel free to ask me right now, or else I'll move on to another topic. So no questions can be seen. That means it's clear. I'm guessing it's clear. Right. So let's move on to another topic, which is prime numbers. We'll get back to LCM. Don't worry about it. LCM is in combination with HCF, and we're gonna come back to this topic again. Don't worry about it. It's a long topic. We do tend to get a lot of questions in GCSEs. So no, we're not supposed to give answers in decimals. All right. If you give answer in decimal, that means you're using calculator. If you're writing the answer without calculator, then this would be your answer, 5 root 3. So I'm just trying to minimize the use of calculator over here, because in exams most of this topic is included in paper 1, which is without calculator. Okay, so just try to simplify the answer to the point where you are needed to use the calculator. Right now there's no need of using the calculator, and this answer would be fine. Okay, you can just leave the answer as it is. Now moving, don't worry, we'll come back to LCMs again, and we'll come back to surge when we're doing some of the questions. Now the last thing for this topic is gonna be prime numbers. So what's a prime number? Can any one of you tell me what's a prime number? So what's a prime number? Okay, so okay, so what's a prime number? Without googling it, can any one of you answer me what's a prime number? So a prime number is basically any number which yeah, so a prime number is any number which comes in its own table, right? It's essentially any number which comes in its own table, right? If I say um, it's not about being an even number or an odd number. It just means that it's primarily the definition of it is it's any number which comes in its own own table only. Okay, it does not have any other number or any other it does not basically have multiples, right? So it cannot be divided by any other number. It can only be divided by one or by itself. Okay, so let's start with a few prime numbers. Can one be, one is a prime number, right? Two is a prime number. We usually don't take one as a prime number because it's obviously it's a basic number. So apart from that, what's a prime number? A prime number is basically, it can be 2, it can be 3. Can 2 be divided by any other number? No, it can't be. It can only be divided by 2 in itself. It can only be divided by itself and 1. So 3 cannot be divided. Can 4 be a prime number? Can anyone of you answer me if 4 is a prime number? Is 4 a prime number? That's my question. Perfect. So your username is a scam and you've replied it right. So a prime number is basically a number which can only be divided by one or itself. You're right. Now my question is 4 a prime number? No, 4 is not a prime number. Why it's not a prime number? Because 4 can be divided by 2, which is, another number. So we get 2. So it can be, when it can be divided by another number to get an whole integer, then it's not said to be a prime number, right? So 4 is not a prime number, right? And 5 is a prime number. 6 is not a prime number, right? 7, although, is a prime number. And then we cannot take 8 as a prime number. We cannot take 9 as a prime number because 8 divided by 2, 8 can be divided by 4, 8 can be divided by 8, obviously. But 9 cannot be divided by 9 can be divided by 3, right? Can 10 be divided by, can be 10 can be divided by 2, 10 can be divided by 5, right? But 11, let's talk about 11. Can 11 be divided by any other number but itself or 1? So we can see that 11 cannot be divided by any other number except for except for 1, right? Or itself. And then similarly something called 13, 12 can be divided by, there's a list of whole prime numbers. So ideally for GCSEs, it's recommended for you to remember the prime numbers up to 100. So you should make a list of prime numbers. So this is your task for today. It's going to be your task to first to find out the square roots, squares of all the numbers till 12, right? And then to identify the prime numbers up to number 100. So all the numbers which are included, which are prime numbers in 100, so you should know them by heart. So this is one of the one of the tasks that I'm giving you for the class, that you should be remembering this, right? Now let's talk about what's a factor. Okay, so let's talk about what's a factor number. Have any one of you heard what's a factor? I cannot see any responses as of yet, so I'm guessing I'll have to explain it. So a factor is essentially a number. No, it's not a negative, like, it's not negative numbers. It's any number that can be divided. All right, so any number that divides a number is a factor, right? So let's say that if I have 6, right? 6 can be divided by which two numbers? It can be divided by 2 or it can be divided by 3 to get me a a whole number. Okay, so it means that 6 divided by 2 gives me 3, which is an integer, right? 6 divided by 5 gives me 2. 6 divided by 3 gives me 2. So that means that 3 and 2 are all factors of 6. Okay, so 3, 2 and 6 are factors of 3. So if I have a big number like 15, maybe 15, okay, so what are the factors of 15? So for that I have to do LCM, right? Least common multiple. So what's the smallest number that 15 can be divided with? Can 15 be divided by 2? No, it can't be divided by 2. Can 15 be divided by 3? Let's see. So 15 divided by 3 gives me 5, right? Which is an integer. So we say that, of course, we can divide 15 by 3. Now 5 can be divided by 5 because it's a prime number, right? So these two are, they are called multiples and they are called factors. They are called both multiples. By multiples I mean that they can be multiplied together to form 15. Okay, by multiple I mean that they can be multiplied together. These numbers can be multiplied together to form 15, right? Whereas these, like 3 and 5 separately, are called factors of 15, because each one of them can be used to divide 15, right? If I divide 15 by 3, it gives me a whole number which is 5. Similarly, if I divide 15 by 5, it gives me a whole number which is 3, right? So these two numbers are also called factors for a reason. Right, do you get it? Is there any question? If you have any questions, then please write it in the comment section below. All right, so if I ask you to find me a factor of 48, find me factors of 48, so you need to mention all the numbers which 48 can be divided with. Okay, so what are the numbers which 48 can be divided by? So what are all the numbers which 48 can be divided by? Right, we do LCM. We perform LCM over it. Okay, so the minimum number with 48 can be divided by is 2, right? So we write 2 over here, and then we are left with what? 24. We again divide 2, okay, and now we get 12, right? So we divide it again with 2, we're left with 3. Now we divide it again with 2, we are left with 3, and now we divide with 3, we get with 1. So we end it here because we're getting 1, right? So all of these multiples are basically the factors. So how can factors be written down? First, if I multiply these two together, so it's going to become 4, and what's left is 2 multiplied by 2, 4. 4 multiplied by 3 is 12. So if I can divide 48 with either 4, or I can divide 48 with 12. So these two are one of the factors, right? Now, if I say I need to find other factors, so there are other factors possible as well. I take these three together, so it's going to become what? 2 multiplied by 2 is 4, 4 multiplied by 2 is 8, right? And this is 6. So 6 and 8 is also a factor. So 6 is a factor, 8 is a factor, and we've devised that 4 is a factor, we've devised 12 is a factor, right? We divide 12 is a factor, right? And now if I say that I take all of these two together, so it's going to be 2 multiplied by 2 multiplied by 2, 8. 8 multiplied by 2 is 16. So 16 multiplied by 3, right? So 16 and 3 is also a factor, right? 16 and 3 is also a factor, right? And now if I say that I take just this 2, okay, and all of them combined, so it becomes 2 multiplied by 2 multiplied by 2, which is 8. 8 multiplied by 3 is 24. So 24 and 2. So 24 and 2 is also a factor. So these are all the possible factors or all the possible numbers that 48 can be divided by, which will give you a whole number. You can test either one of them. So let's say if I test 8, if I got it right, so 48 divided by 8 gives me what? So 48 divided by 8 gives me 6. So it's a factor, right? It gives me a whole number, right? Okay, so I'll explain the multiple parts again. Okay, don't worry, I'll explain it again. So let's say that a number we have a number 48. Okay, we need to find factors for that. For that we need to do multiples of 48. So 2 is a multiple of 48. We're left with 24, right? We're going to divide it with 2 again, so we are left with 12. And then we're going to further divide with 2, we're going to left with 6, then 2, we're going to left with 3, and now 3, and we're going to left with 1. All right, so all of these are multiples of 48. Now we make pairs, different pairs, in order to find out. Now we make different pairs of these multiples in order to find out the factors. Okay, so how are we making pairs? Okay, so first I take this 2. Okay, first I take this 2. Okay, and I combine them all. I multiply these all multiples together. So 2 multiplied by 2 is 4. 4 multiplied by 2 is um, 4 multiplied by 2 is 8, and 8 multiplied by 3 is 24. So 24 and 2. So these are the two factors I get. So one factor is 2, one factor is 24, right? Now I have to find other factors as well. So the other factors would be, if I take these two combined, so it becomes 2 times 2 is 4. And now I combine the rest of them. It's 2 times 2 is 4, 4 times 3 is 12. So another factor which I get is 4 and 12, right? And now which other number can be made? So if I take these three twos together, so it becomes 8, and then this. So 8 and 6 is also a factor, right? Do you now get it? Do you get it how I'm forming chunks of different multiples together in order to find out the factors? Okay. So now if I say that I take these four twos together, so 2 multiplied by 2 multiplied by 2 multiplied by 2, it becomes 16, and then 3. So I take 3, and 16 is also a factor. So all of these are basic factors of 48. So if you take any one of these numbers and divide it with 48, it's going to give you a whole number or an integer. So what's basically a whole number? So what's a whole number, right? If I tell you what's a whole number, okay, whole number or an integer, or an integer. So what's a whole number or an integer? It's basically any number. It's basically any number uh, which is real and is not in fractions. Okay, so let's say 2 is a whole number, similarly 4 is a whole number. So in a number line which I drew earlier. So this is 0, then this is 1, this is 2, and it goes on to a whole series which is going towards positive. So infinity. It might be 5 over here, it might be -1. So these are all integers. Okay, so the whole numbers, right? 2, 4, 6, 8, 12, 11, 13, any number which is not in fraction is an integer. Okay, or an whole number. Both of these names are used for them. Okay, so did you get the multiple parts? Did you get the parts where I devised factors and multiples? Do you get it now? Perfect. So I hope I'm clear to all of you now. I'm clear to, yeah. So moving on, um, I'm gonna just show you how to devise. So these basically are called, like what I've done here, right? I'm finding out different factors from for 48, right? But these numbers which I just wrote down, so I can write it down separately, like 2 multiplied by 2 multiplied by 2 multiplied by 2. There are four twos, right? And then multiplied by 3. So all of them are prime numbers, right? Is 2 a prime number and 3 is obviously a prime number, so all of them are prime numbers, hence they are called prime factors. They are called prime factors. Okay, factors are any, so basically 2 and 3 are the prime factors of 48. So 2 and 3 are called the prime factors of 48. Why are they called prime factors? A, all of like 2 and 3 both are prime numbers, right? And 2 and 3 can be divided by 48 to obtain a whole number. Okay, so there are two reasons. One reason is 2 and 3 are both what? Are both prime numbers, are both prime numbers themselves. And then another reason is they can be divided by 48 to get an integer, right? Do you get it? Why are they called prime numbers? So there are two reasons for that. Reason number one, that 2 and 3 are obviously prime numbers themselves. And then reason number two, that they can be divided by 48 to obtain a whole number, right? So this is essentially what we are doing, right? And now I have a few questions for you guys. Okay, so let me just open up some of the questions. Now the question is write down the prime factors of 36. Okay, so the question is write down the prime factors of 36. So what are we gonna do? First, we're gonna take 36, right, and divide it. Okay, so what's the difference between whole numbers and integers? So there's no difference between whole numbers and integers. Basically the exact same thing, right? This is what I was telling you, that whole numbers and integers are basically the same thing. Okay, so now the question. let's get back to the question. So we have to write down the prime factors of 36. So what are the prime factors of 36? Okay, so once we divide it with 2, we get 18, right? We get 18, right? So can 18 be divided further? Yes, it can be. So what's the least number which it can be divided with? It can be divided with 2, I see. So if I divide it with 2, we get 9. So now what's the least number which can be divided with 9? So there's 3, right? So we get 3 in back, 3 back. 3 threes are 9, right? So we divide 3 with 3 and we get 1. Here's when we stop. So we get 2 multiplied by 2 multiplied by 2 multiplied by 3, I'm sorry, and then multiplied by 3. So basically 2 and 3 are the prime factors of 36, right? So 2 and 3 are the prime factors of 3. And the factor decomposition, this is called, this how I've written it, it's called LCM. LCM, least common multiples of 36. It has a different name in GCSE as well. It can be called um, prime factor decomposition. Okay, so there are two names for it. It can be called prime factor decomposition as well as the least common multiple. Okay, so these are the two names for how we've written the answer. Okay, do you get it? Is there any question, anything that you want me to answer you, or is there anything that you do not understand? Please feel free to ask me right now, as we're nearly towards the end of the class. I just wanna answer all of your questions. So if you have any questions, please feel free to ask me. All right. So I don't see any questions from you guys. That means everything is understood, everything is clear. Okay, so let's go to some of the questions which I have for you guys right now. Okay, so these are past papers question. Okay, this is not something that I've written. Okay, so one of the most common questions that come across is this. Okay, so they've asked you, find out the cube root of 4913. Okay, so what do we do? And remind you that this is without calculator. So 4913 and then cube root. Okay, so our first and primary step for solving this would be to take, I am getting a response for do it again. Do what again exactly? Do you want me to explain this question again? Okay, so they have asked you to write down the prime factors of 36. All right. So what do? We first take the LCM of 36. So we divide 36 with 2, we get 18, right? And then we further divide 18 with 2, we get 9. Now, what do we do? What do? We divide 9 by 3. Okay, so we get 3. And then we divide 3 again, and we get 1 in response. So we write all of these multiples in this form. Okay, 2 times 2 times 3 times 3. Okay, so this is called with two names. One is prime factor decomposition and the other is LCM. So you can call it either one of them. It can be called as prime factor decomposition, right? And it can be called as LCM of 36 as well. So both are accepted, right? And we can see that as there are only two numbers, 2 and 3, so we say in the answer, we say 2 and 3 are the prime factors of 36. Do you get it? So 2 and 3 are basically prime factors of 36. Is there any question now? Okay, so this was the question in hand. Okay, for prime factors, I can obviously do one more question. Let's keep this for the next class, okay? As we are short on time, we'll do this in the next class. So now, if we just do another question for this, okay, let's do another question for this. Now, instead of 36, we have 54. Okay, so we need to find the prime factors for 54. So what do? We take 54, right? And then we see the smallest number which is divided, which 54 can be divided with. Okay, so 54 can be divided with what? 2, right? And we get what? We get 54 divided with 2 is 26, 27, right? So 27. And now 27 cannot be divided by 2. Can it be divided by 3? Yes, I think it can be divided by 3. We get 9. Alright. So we further divide 9 with 3. We get 3 in return. And now we divide 3 by 3. We get 1. Okay. So we say that 2 into 3 into 3 into 3. These are all the these are called prime factor decomposition. This is called prime factor decomposition. Okay, decomposition, or it can be called as LCM of 30. Oh, sorry, of 54. 54. So which are the two prime factors? So we see 2, we see 3. So these are two prime numbers which are the factors of 54. So we say 2 and 3 are the prime factors of 54. Do you get this? Do you understand this problem? How many of you still have any problem understanding this? Okay, now so we'll do another question regarding prime factors. Let's do another one. Okay, so we take 90 this time. Let's find out the prime factors of 90. Okay, so we take 90. Can 90 be divided by 2? Can 90 be divided by 2? Yes, 90 can be divided by 2. We get 45, right? Can 45 be divided by 2? No. Can 45 be divided by 3? No. Can 45 be divided by 5? Yes. 45 nines are is 45, right? And now can 9 be divided by 3? Yes. We left with 3 and then this. Okay. So we write down that 2 times 5 times 3 times 3. Okay, so this is the LCM. This is the LCM of 90 of 90, right? And what are the prime factors? Prime factors are 2, 5 and 3. So 2, 5 and 3 are the prime factors of 45. Okay, why are they called prime factors? Because you can use either one of these, like you can use either 2 or 5 or 3 to divide 90. Okay, so these are the prime factors of 90, sorry. So of 90. So you can use either one of these to divide 90. Let's see. Can 90 divide by 2? Can 90 be divided by 2? Yes, we've seen that it is equals to 45. Can 90 be divided by 5? 90 divided by 5 gives us what? 18. So yes, it can be divided by 5, right? Can 90 be divided by 3? Yes. 90 divided by 3 is 30. So you see that all of these are integers. Hence, 2, 5 and 3 are the prime numbers which can be used to divide 90. Hence, they are called the prime factors of 90. Okay, so things that we've learned today, we've learned that what's a rational number, what's irrational number, all right, what surds, what are basically surds, we've learned that, right? We've learned what are square numbers. Okay, we've learned what are real numbers. We've learned what are prime numbers. Okay, we've learned how to take out the LCM of a number. We've also learned how to um, take out the factors of any number. So what basically are factors? Factors are numbers which can be divided by any number. Okay, so what are rational numbers? Rational numbers are basically numbers which can be divided, right, which can be written down in fractions. Okay, irrational numbers are what numbers? Numbers which cannot be written as a fraction, right? What are square numbers? Square numbers are numbers which can be multiplied by numbers which are multiplied by themselves. The answer of that is a square number, right? So 6 times 6 is 36. Similarly, 4 times 4 is 16. Similarly, 8 times 8 is 64, right? So this 64, 36, and 16 are all square numbers. Now we've learned what is a prime number. Prime number is basically any number which only comes in its own table, or it comes in one's table. That's it. It cannot be divided by any other number, right? Similarly, we've learned what are surds. So surds are basically any like a square root of any number is called square surds, or cube root or root basically of any number is called one. We've learned how to find out the answer of a root. We've done a couple of examples in this regard. We found out the square root of 50, right? We found out the cube root of 27, different things. Okay, now we've learned how to find out the LCM of a number. So LCM is what? LCM is least common multiple of a number, right? So basically, this is what we've learned so far in our lecture today. And in case you have any queries, feel free to join the next session, and we will be discussing them. One of two things that you need to do before the class on Friday. One, you need to remember all the squares of numbers from 1 till 12, like square of 12, square of 11, and all of it. And then what you need to do is you need to remember the prime numbers that are included from 1 to 100. All right, so that's it from my side for today. I hope you really enjoyed the lecture. Feel free to ask me. All right, so cheers, that's it for today. Have a great day. Bye.